Hi, and welcome to my video on solving equations with ln, natural logarithm, and this is part 3. I made up this question to help you think more along the lines of the inequalities and the absolute value and ln is all combined. So if you want, you can pause your video to see if you can solve for x. The absolute value of the ln of x minus 2 is greater than 1. I'm going to solve it algebraically first. Again, you can pause your video and see if you can do this before I do it. I have a special way of solving absolute values, and it's in my unit on Algebra 2 on absolute value unit, and in that unit there's videos on absolute values in dealing with inequalities. So the way I handle the absolute value is different than most books or most teachers. I go the negative ln absolute value, the bracket of x minus 2 is greater than 1, and greater than is an or, and the positive of x minus 2 is greater than 1. So I keep the greater than 1 here, and I go the negative of it and the positive of it. And greater than is on the outsides, so it's to the right, which is greater than, and to the left, which is negative. And I do the negative first. In relation to right here, the negative log e of x minus 2 greater than 1, and again the log of x minus 2 base e is greater than 1. So I change ln to log base e, change ln to log base e. Now I'm going to solve this, and I have a negative, so I multiply by, divide by -1, or multiply by -1. So the log base e of x minus 2, negative times negative positive, positive times a negative is a -1. And when you divide or multiply by a negative inequality, when you multiply an inequality which is greater than by a negative, you change the direction. And there's an or coming down through here, and so two of them are solved. So we got e base x. I'm going to put the x minus 2 is less than e to the -1, base exponent number. But I want to put the x minus 2 in front because this number here is always greater than this one every time you do a log. And you can check it out and do say the log of 20. When you have base e, this is 20, and this number will be always less than 20. So that means we have x is less than e to the -1 plus 2. And this bracket is not necessary here. And again, right here, I have x minus 2 is greater than e to the 1, base exponent number, and x is greater than e plus 2. Now, these are two answers, but there's something special about this one, because we have to remember that the x minus 2, the ln has to be, of the number has to be greater. So this x minus 2 has to be greater than 0. That means x has to be greater than 2. So even though these are answers, but you're going to say, how do I know what these answers are? Well, if you take your calculator and change the e to the -1, take your calculator and go e to the -1 plus 2, you'll get roughly 2.37. And if you take your calculator and change e plus 2, e is 2.72, so that's 4.72. So this gives you a better perspective on what this number is doing in relation to the answer. So what happens if you take all numbers that are greater than 4.72, it'll make this true. But over here, what happens? We have less than 2.37. But the log here has to be greater than 2. So really, to this answer here, you have to go 2 less than or equal to x less than 2.37. Because even though this says right here that is less than 2.37, that means you can have, a 1, a 2, a 2, a 1, a 0, -1, so on. But that's true for this inequality right here. But we can only go down as far as 2. So the answer is really, if you think about it, is 2 less than or equal to, instead of having 2.37, then we can have e to the -1 plus 2. Or, now we take any number greater than 4.72, and so that means that x is greater than e plus 2. Again, e is 2.72, so we take a 5, a 6, a 7, etc. So these are the answers for the values of x that fit this inequality here. So I also decided, well, that's good, but what about if we explain this geometrically? Imagine trying to find these answers. These are the exact answers geometrically. You wouldn't be able to do it. So algebraically, it tells you that these are the two answers. But let me explain the geometry. Let's look at the equation. Let's look at the equation that y equals ln absolute value of x minus 2. Notice the inside of this is the ln of x minus 2. If we take this equation and work it out, we put an x and a y. What we have is that we have x minus 2 is greater than 0. We have x minus 2 is greater than 0. That means x is greater than 2. So we have to take the x values that will go into this table to be greater than 2. But we also have to remember that x equals 2 is the asymptote. That's the asymptote. So the asymptote is 2. X equals 2, and the asymptote is down through here. There's the asymptote. So this log, y equals log of x minus 2, goes to this asymptote. So let me explain. If I use greater than 2, let's take 2.1. Take 2.1 and put it in your calculator. You get 0.1. The ln of 0.1, if you check with your calculator, is 2.3. Let's go further. Let's take the ln of 2.5. 2.5 put in is 0.5, and the ln of 0.5 is a negative 0.7. And I keep growing the x values to the left. Put a 3 in. 3 in, you get the ln of 1. The ln of 1 is 0. You put a 4 in, you get the ln of 2, which is 0.7. And I'm just going to, the ln of 5 is, put a 5 in, you get the ln of 3, and the ln of 3 is 1.1. And just put a 6 in, you get the ln of 4, which is 1.4. And if you get, put a 10 in, you get the ln of 6. Put a 10 in, you get the ln of 6, which is 2.1. So if we take these, that means it's a graph it here. So this is 2, so 2.1 gives 2.1 is roughly here. So there's, I'm just estimating. And 2.5 is in the middle, so it's a negative 0.7. 0.7, there's 0.1, so let's say is right there. And 3, the ln of 3 is 0. So when I put a 3 in, I get the ln of 1. So a 3 gives me a 0, so x is 3, y is 0. X is 4, y is 0.7. So there's 1 right there. There's 0.7. 5 gives me 1.1. So there's 1 right here. 1.1, a little bit higher. 6 is 1.4. 6 is There's 2 right there, so 1.4, a little bit higher. And let's go over to 10. 10 gives me the ln of 6. 10 is 2.1. So there's a 2. So let's say 2.1. So this is the graph of the exponential. There it is. Now, what happens if we look at the equation y equals the absolute value of the ln of x minus 2. This is x and y now. So we get the same values for x. So we get 2.1, 2.5, 3, 4, 5, 6, and 10. But we do the absolute value. So if you take 2.1 and plug it in, you get a negative 2.3. So the absolute value is 2.3 because you can't, there's no negative y's. So that means this one is 0.7. And this is a 0. That's okay. That's 0.7. That's 1.1. Because they're positive, they're okay. So what happens, and I'm going to use a red pen now, is that right here is 2.1. Instead of being a negative 2.3, it's a positive 2.3. So it's over here. Hope you can see the red pin. And when you have 2.5, which is right here, you get a positive 7, which is here. And when you have 3, you get a 0. When you have 4, you get 0.7. So you get all these. These are the same here. So I'm just going to put, if you can see it. Red pen. Trying to make the red pen. Now I'm going to trace out, it comes, it does this. So the absolute value of that log is the absolute value. Takes the negatives down here and makes them all positive. So the graph goes up there like that. And this is still this branch here because they're all positive. So the red is representing the graph of this absolute value. So when you take the line, so this is greater than 1. So that's the same as saying y is greater than 1. So I put it black there now. So this expression is greater than 1, so that's the same as saying y is greater than 1. So what we're doing is we have a horizontal line, y is 1. So there's y is 1. So these are all the y values up here that are greater than 1. So therefore, as you can see, between 2 and 2.4, between 2 right here and 2.4. So in the absolute, this solution for greater than 1 is this one. So there's that point right there is 2.37. And this point here is a 2. So this is the graph that we have right here. This is the graph that fits it, this piece of the graph. And this is 1. So when you look at greater than 4.72, this point here is 4.72. So it's this. So the solutions are this and this. That's those right there. And to illustrate that further, I have a graphing calculator. I'm going to slide my paper up. I have a graphing calculator now that we're going to look at. And I want to show you the graphing calculator, how, just slide that right up. Okay. Now I'm going to turn on my calculator, and I have the graphing calculator. I have some equations in here. So the first equation that you see is ln of x minus 2. So I have that highlighted. This is highlighted, and these two are not highlighted. So my graph is, so there's the graph that graph right there is this one going over here. So that's the asymptote. There's x equals 2. That's the vertical asymptote. And so now what I'm going to do is go back into my equations, and I'm going to take that one off, and I'm going to, now I made this one dark, which means I'm looking at the graph of this. So what you see, watch when I, okay. So, okay, there we go. So what happens is that this piece of the graph down here, because of the absolute value, I still have this because these are positive, but all these negatives down here became positive. So this graph leaves here. Instead of going down there, it's going up here. So this is the absolute value graph we're looking at. Now, what I'm going to do now is I'm going to go down, right down below, and I'm going to highlight. This is y equals 1. So now I'm going to have the graph of the absolute value, which is this one right here, and this one. So you're going to see y equals 1 going across the screen. So we're looking at all the values of y that are greater than 1. So that's this piece of the graph right here, which is this. And it's not greater than 1 in here. It's not great. It's greater than 1. You can see in between here and here, it's less than 1. And there's greater than 1 here. So it leaves this point right here. This is what I want. So greater than 1 starts right here, and only this part all the way up here. So it starts right there, and this is the, so that's this. So between 2 and 2.37, the graph between 2 and 2.37, y is greater than 1. So I just thought I might mention that, explain it to you, that how it all fits in, because to understand how it all fits in makes you better in math. So that's just one problem I wanted to explain, which takes a while, explaining the background. So hopefully, if you like my video, click the like button. And if you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.